moving on here, these are called squares, and even as it says here, they are not anything new. In fact, it says they deserve a special note. I don't even know. I don't even know if that's true. We're just going to do this exactly the way we've done it before. Notice there is no missing term in the middle, so I can't do that trick where it's the perfect numbers or whatever. I have to do this very traditionally. So I have the left side, so x and x will get me the x squared. And then I've got 5 and 5 will get me the 25. Or I guess I could do 25 and 1. Now I do need to get, this is a 5x and that's a 5x, which gets me a 10x. It's not quite what we want. We want a negative 10x. So because I don't have the right symbol, I can change the sign. So this is a positive 5. I'll make it a negative. This is a positive, so I'll make it a negative. And sure enough, I still do preserve negative 5 times negative 5 is 25. I do preserve that right-hand side, multiplies to the right-hand side. And now my diagonals are x times negative 5 is a negative 5x. And then x times negative 5 is also another negative 5x, which if you added those will get you a negative 10x, which is my middle term. So I get x minus 5 and x minus 5. So my answer is x minus 5 times x minus 5. So again, nothing new here. However, I notice that these are both exactly the same. They're identical. So I can write them as x minus 5 and say, hey, there's two of them, so squared, which is why this is called squares. It just means that the answers that you get, both factors, are the same. So moving on here, I do notice here that this is 25. That's a perfect number, which is 5 and 5. 4 is a perfect number. That's 2 and 2. So I do need the x. Now this is not the same where you can make one positive and one negative because your middle term is not a 0. It does exist here. It's a negative 20x. So I'm always, when I see that this is a perfect and this is a perfect, I just make my answers perfect. So 5 and 5 is 25 and 2 times 2 is 4. And then that's how I started off with. So this diagonal is going to be a 10x. And that's also a 10x, which if you add them get you 20, which is what I need, except I need a negative 20. So I got the right number. I need to change the signs. Sorry about that. The announcements just came on. So there was a 10x, and I need, negative 10 and 10 is 20. I need negative 20, so I'm going to switch the sign. So a positive 5 will become a negative 5, and this positive 5 will also become a negative. So I switched them both to negatives. Now this diagonal is a negative 10x. And that one, 2x times negative 5, is still another negative 10x, which if you add them, get you a negative 20x, which is my middle term. So I've done that right. So I've got a 2x minus 5 and a 2x minus 5. And as you notice, they are both the same. So I will go 2x minus 5 all squared. 2x minus 5 all squared. Okay, so continuing on here, again, I notice immediately that 36 is perfect and 49 is perfect. When they're both perfect numbers like that, then I immediately just start by going, okay, well, I'll do 6 and 6, 7 and 7. Of course, this side needs an x and an x. So yes, 7x times 7x is 49x squared, and 6 times 6 is indeed 36. So those are preserved. Now I can do my diagonals. 6 times 7 is going to be a 42x. 7x times 6 is another 42x. And if you add them, you're going to get 84x. Oh, perfect. That's exactly what I needed. That is my middle term. So I have a 7x plus 6 and a 7x plus 6. 7x plus 6. There we go. And again, those are identical. So our answer is going to be a 7x plus 6 all squared. Okay. So moving on to the ones below here, this is going to be doing a little bit of everything. We've technically done all of the stuff the exact same way. It's just sometimes that middle term is missing and it's a 0. We got to keep that in mind. But otherwise, these are all trinomials. The one thing now, though, that we are going to do is we're going to do what we did at the very beginning, the very first chapter, which is taking out something common. So when it says factor completely, that means that if there's something common that we can take out, let's do it. So the GCF of this thing, they can all be divided by 5. And this has an x squared, this has an x, and this has none. So the smallest x's is none. So what we'll do is take out a 5. So we take out a 5, and that leaves you with, oh, I think I have to give myself a little bit more space here. Take out a 5. And so what we did is we divided everything by the GCF. So 5 over 5 is 1, and then there's just an x squared. 40 over 5 is going to be a -8, and then there's an x, and 35 over 5 is a 7, so a plus 7. And I don't need to write that 1. Okay, and now that I've done that, I can do this. Factor trinomials, so x and x multiply to the left side, and x squared. And I guess 7 times 1 is my only option. 1 times 7 would be the same thing. So this diagonal is a 1x. This diagonal is a 7x. That adds up to 8x, which is not what I want. I want a -8. So I need to change the signs. So this is a positive. I'll make the 7 a negative, and the 1 is positive, so I'll make it a negative. Now my diagonals are going to be a -1x when I multiply, and x times -7 is a -7x, and if I add those, I'll have a -8x. Perfect. So when I write my final answer here, and you want to be really careful how you do this, you're going to have the x minus 7 and the x minus 1, so let's write that down. And then you have the 5 that we took out, so we're going to put that down in front. And we can't forget that 5. That's probably the most common thing that people get wrong. So just don't forget to include that 5. That is considered factored completely. Okay. Let's take a look at B here. What is my GCF? If there's anything here, it's in common. Sometimes your GCF is nothing, and so you just do a normal factoring. But here, it looks like they can all be divided by 7. And the highest x, okay, so the smallest x that they all have is the smallest x is an x, so they all have at least an x in common. So I can, I guess, just divide by 7x. So divide that by 7x, divide that by 7x, and divide that by 7x. Okay. So 7x is what we divided out in front. We factored it out. And now 7 over 7 is a 1. And then there's 3 on top, 1 on bottom. That leaves a remainder of 2. Minus 5. There's 2 on top, 1 on bottom. So there's 1 remaining on top. And then 42 over 7 is a 6. And there's 1 on top, 1 on bottom that will cancel. And I don't need to have this 1 out in front. Now let's factor this trinomial here. X and x will get me the left side, which is an x squared. Now 6, well, that could be a 6 and a 1 and a 3 and a 2. So I'm thinking about -5 here, and it's like, well, if I made this a -6, -6 plus 1 would get me -5. But if I made both of these negative, -3 plus -2 would also equal -5. So which one do you choose? Well, these two, if you multiply them, you'll still get a positive 6. So that's what I'm going to do. I'm going to choose those ones. Now, you could just have gone 6 and 1 and done your diagonals and say, okay, that doesn't work. And so then you try 3 and 2 or whatever, and you can do it that way. But I was trying to do read a little bit into it. So this is a 2x, that's a 3x, that's a 5x. But like I said before, I need a -5x, so I'm going to have to make them both negative. So this diagonal, x times -2, is a -2x. X times -3 is a -3x. And so if I add those, I'm going to get a -5x, which I had already seen when I wrote those out, but I've double checked it. That does work. So I have an x minus 3 and a x minus 2. And that's not your final answer, because you can't forget to also include this 7x out in front. So again, don't forget that. That has to be brought down. I'll just zoom out here. And let's try C as well. Okay, take a look at the GCF here. GCF. Now I know they can all be divided by 9. Now what's the smallest x? 3, 2, 1. Well, 1 is the smallest, and the smallest y. y2, y2, y2. Okay, well, y2 is the smallest. So they can all be divided by 9x y squared. 9x y squared and 9x y squared. So I will factor out that 9x y squared, and I will be left with 9 over 9 is 1. 3 on top, 1 on bottom, leaves me with just a 2. And both y's, y2, y2, those will cancel. Plus 6. 2 x's on top, 1 on bottom, leaves me with 1 on top. And y2, y2 will cancel. And 36 over 9 is a 4. 1x on top and 1x on top, those will cancel. And the y squareds, 2 on top, 2 on bottom, those will cancel. So it's just what I'm left with right here. The 1 I do not need to write, so I will erase that. Okay, let's try this here. X and x will multiply to x squared. And I need to do 4. Okay, well I'm thinking now that this probably won't work, because 4 and 1 is 5. And, okay, so how can I change this here? Okay, well, let's see here. I think that I'm going to make this a 45. So instead of a 36, a 45, which probably will match up with yours already. You're probably wondering, what? This is 36. Okay, so let me just start with this. Now it's 45. So 45 divided by 9 changes this to a 5. Okay, so the only options I have are a 5 and a 1. Now if I check my diagonals, x times 1 is a 1x, and x times 5 is a 5x, and if I add those together, sure enough, I have a 6x. That's exactly what I needed. So I have an x plus 5 and an x plus 1. And we can't forget the 9xy squared that is out in front. 9xy squared. And this is considered fully factored. By the way, you could put those in brackets if you wanted to, but usually the GCF we don't. We just leave it out in front without brackets. It's common practice. Okay, so there's the whole question now with me making the changes, and we'll do the next ones in the next video.